read the question, it says that given the function this one and find the differentiate the given function. First part is by using product rule. Second part is by using by multiplying. It says by expanding the product to obtain a single polynomial. So that means first multiply and get a single polynomial and then do the derivative. For the same question, do the derivative in different ways. Making sense?
Okay. Yes.
Yeah. And show that the answer is same. So yes, here we
Okay.
are supposed to show that both the derivatives answer are exactly same.
Yes.
Let me know once you are done, Miraj.
Okay.
Yeah.
Done.
Okay, Miraj. So these are the questions. Okay, today I have left so many questions for you. Please try it and let me know in the next class. Are you able to do it or not? Okay, we are almost there. We are done with this one. Next class, we can take the parametric form. Okay.
Yes. The next topic.
uh, mm, First I'll finish this one. Wherever you'll be having doubt, I'll take that one. And when we have two more exercises. Okay. However, these two exercises are really small. Just the first one is having 11 questions, the next 5.6, and the next one 5.7 we are having where we have to do second order derivatives. 17 questions are there. But all these questions are exactly just same with each other. Okay. So two more exercises we are having, and yes, you tell me what is the next chapter you want me to take.
Uh, I'll check. The-
Okay. So you can let me know in the next class. And yeah, yes, Miraj, today I'm keeping this much over here. Okay.
Okay. Yes. By the way, I have done many chapters already. So, uh, yeah, we can like
Yeah. You have already done all the chapters previously, right?
yes.
Okay. So next class, you can let me know what is the next chapter you want me to take. And yeah, where you are having confusion. Okay.
Okay.
Yeah. So yes, Miraj, I'm keeping this much over here. And let's continue it in the next class. Till then, take care of yourself. Thank you.
Okay. Thank you. Bye.
Thank you.
Yes, am I audible? Nabiha, Sanidhi, Mariam?
Yes, ma'am.
Okay. In the last class yesterday, we've completed it till here. One question was left in from powers, and collision was a topic I told you that we'll be completing. So let's wrap up this chapter. See, this says a body of mass 100 kg is moving up an inclined plane with a velocity 10 meter per second, slope 1 in 5. Sanidhi, what is meant by slope 1 in 5? Sanidhi, recall slope 1 in 5. Which trigonometric was it related to? Sine theta.
Yeah,
Okay.
okay.
So this is actually sine theta is given you 1 by 5. Whenever it says no, slope 1 in 5, that means sine theta is given to you. Using this, you can calculate the rest of the information too, but this is primarily important. Now, sine theta is provided. Okay. It is calculate power spent by the energy. Mass is given to you as 100 kg and velocity in meter per second. Okay. Now see, what all things will be acting? Downwards, we'll have the weight of the body acting, that is mg acting. Now, as I discussed earlier, also you have to resolve the vectors. We discussed it in detail in laws of motion for the motion under inclined plane problems. So, same thing will be valid here as well. This theta, this will be mg cos theta, whereas the perpendicular one will become mg sin theta. Now the mg cos theta will be balanced by the normal reaction. So along this perpendicular to the plane, you don't have any motion required. So you will have mg sin theta that is present. This mg sin theta is actually a force that is giving a push to this body mass, which is moving up. Okay, because this is countering the applied force. So here when we talk about power, power is equal to force into velocity. This was also one of the modifications of the formula that we saw last. But here, force that is given, force is equal to mg sine theta. See, the task of this question is two tasks are there. One is to identify the sine theta. Second is to find out which force is actually responsible to cause the body to to move upwards, uphill. So to move the body uphill, you have mg sine theta responsible, not mg cos theta. Mg cos theta is just balancing across the perpendicular to the plane. That is the normal reaction. So force that is responsible will be mg sine theta into velocity. Now I think every information is provided. Mass is 100, g is 9.8 meter per second. Sine theta is also given as 1 by 5 and the velocity is 10. This will become 2. This is almost 10, so that becomes 2000 watt approximately, which is equal to 2 kilowatt. That's the power answer to this question. Now, there is one note point which I'll mention. In case if you didn't have sine theta's rule, suppose you had cos theta's rule, then the slope is given to you. Let's say slope 1 in 5 is given. Slope is 1 in 5. This is given to you. So what you'll do, sine theta is equal to 1 by 5. Now, this you should know when we write sine theta, it is actually made up of perpendicular upon hypotenuse. So here also this means that the perpendicular is given to you and the hypotenuse is provided. Okay, sine theta is given to you, the perpendicular upon the hypotenuse is provided. So suppose if you have cos theta as requirement, let's say you want cos theta in your question. So you know cos theta is base by hypotenuse. If you need tan theta is perpendicular upon base. These you already know. So if I have perpendicular and hypotenuse information with me, I can get the base, only the base is missing. Let's say this is theta here. This will be the perpendicular, this will be the base, this will be the hypotenuse. Correct class? if I have the perpendiculars information, if I have the hypotenuse information, calculation of base isn't difficult. If we apply the Pythagoras theorem over here, hypotenuse square is equal to perpendicular square plus base square. From here we can say base square is equal to hypotenuse square minus p square, which can be further written as b is equal to under root h square minus p square. For example, in this question we can say base will be hypotenuse is 5. So 25 minus 1, that is root 24. That is the base. Now suppose I had to calculate cos theta, I would have directly used base is root 24, hypotenuse is 5. Okay. Or if I had to calculate tan theta, I would have used perpendicular is 1, base is root 24. So using sine 1 in the slope 1 in 5, if this is given to using this information, you can calculate sine theta, cos theta, tan theta, cot, cosec, any you can calculate using this. You should just know perpendicular and hypotenuse are given. If these two information are given, you are easily eligible to use Pythagoras theorem. This is a concept that I want to tell from this question. So this question is a little important because it has a lot of concepts in it. First is usage of slope 1 in 5. Slope 1 in 5, using that you can calculate any trigonometric function which you want. Then apart from it, you should know which force is responsible to cause the power. Am I clear to all?
Yeah, ma'am.
Others? Neither is doing twice. What about the ones who are doing for the first time?
Yes, ma'am.
Yeah? Okay, write it. Then let's start with collision. Okay, last topic of work, energy, and power. Work, energy, and power are actually completed. There's one more topic, collision. That will complete the chapter. Please write it first. Class, so let's start with the collision part. I hope you all have written. See, collision is basically an event that occurs when two bodies are in contact with each other. Now, there are basically three steps that occur for collision to occur. This is the scenario before collision. Okay, initially what happens? This is the initial case. Two bodies with their individual masses m1, m2 and their individual initial velocities u1 and u2 are moving. Okay, that's the scenario before collision. Then both of these collide. That is your actual event which we are focusing on. That is collision. Collision occurs, both the bodies come in contact with each other. Both the bodies exert equal forces on each other. So during collision, the net force is zero. Okay, then what happens is this is the scene afterwards. The bodies, the masses, they get separated. Both of the bodies get separated to each other from each other, and they move with their individual velocities. Okay, so this is the scenario before collision, during collision, and after collision. And what is collision? Collision is an isolated event in which large force acts on a body, but for a very short duration of time. And we've already studied this in laws of motion, that forces that act for a very long duration, for a very short duration of time, are known as impulsive forces. Like I gave you an example that when the ball hits the bat, I think I told you this one, and when the when the hammer strikes the nail, these two things I gave. So anything that occurs for a very short duration of time, but the force has a greater impact, is known as the impulsive force. So why is this an impulsive force as example? Because the velocity is changed. The collision is such an event that has the audacity to change the initial velocities of the body and give it a new final velocity. So, of course, collision is an isolated event, and the force that is required are impulsive forces. Physical contact is not necessary. Physical contact is not necessary in the sense before collision. It's not necessary. Both the bodies should be moving with each other. Even if they are moving separated from each other, one can exceed its velocity, overtake, and then collide and then separate. Okay, and there are various kinds of collisions. You have elastic collision, you have inelastic collision, and both of them are possible for one-dimensional motion and two-dimensional motion also. Head-on collision means in one dimension, like both the bodies have either collided from both opposite ends. That is one possibility. Or the other possibility is that both of them are moving and one overtakes and collides. That is the possibility in elastic and inelastic, both in 1D. What's the difference between elastic and inelastic? That I'll tell you. But majorly, head-on collision is this. Oblique collision means when the bodies collide either from both the ends or from together, but after collision, both the bodies move in different directions. Okay, one body, let's say this moves in this direction, one body this moves in this direction, they move in different directions. Means making some angle with the plane. That is known as oblique collision. Now coming to the fact that what is the difference between elastic and inelastic collision. So in C, the inelastic one, this I, inelastic one, second one, there is loss. Whereas in elastic, E, inside elastic, this one, because it's a little confusing, inelastic and inelastic. So in the first one, everything is conserved. The basic difference is that. Now, what all things are conserved and what all things are not conserved in elastic. First of all the conservative forces are present in the elastic, and non-conservative one, this dissipative one, are present in inelastic. Remember, in this chapter, only before starting with potential energy last weekend, we discussed conservative forces as the one which depend on only the initial and the final points. They don't depend on the path that is traveled, right? Whereas the inelastic one, the second one, it depends on the path traveled, as well as this is dissipative in nature, which dissipates in the form of heat and sound. Second is there is no loss of energy here. There is not loss of energy. There is no loss of energy. Whereas here, loss of energy is there. Of course, when non-conservative forces are involved, loss of energy will be there in the form of heat and sound. Okay, now coming to momentum and kinetic energy. See, momentum is conserved in both of these. But kinetic energy isn't conserved in both of these. Kinetic energy is conserved in elastic. It's not conserved in inelastic. Okay, here kinetic energy will not be conserved. Why is this important apart from the definitions that will be asked or the differences that will be asked in the exam? For the application in the exam, in the numericals, if you have some equations, you can construct kinetic energies conservations equations, momentum's conservations equations, right? But here you can't construct the kinetic energies one. So you should have it in your mind. You can't conserve kinetic energy in the inelastic. Now, total energy, as we discussed earlier only, I think last weekend, last Sunday, we discussed that total energy means mechanical energy is actually the sum of kinetic and potential, whereas total energy is the entire energy that are stored. So, kinetic energy and potential energy both are conserved in elastic, right? So, the mechanical energy will also be conserved. But since kinetic energy isn't conserved, so how can you have the total or mechanical energy conserved in inelastic? So it isn't conserved. That's the major difference. Loss of kinetic energy is the major point that differentiates between the two. And since kinetic energy is different, mechanical energy is also different. Otherwise, but momentum remains conserved in both of them. That is one major difference about loss of energy. And why are we having loss of energy? Because of the actual fundamental concept of conservative and non-conservative forces. So these points should be clear to you completely. Okay, conservative forces are present in elastic, inelastic, non-conservative. No loss of energy, loss of energy in elastic. Momentum, this P is momentum. Momentum and kinetic are conserved, they are not conserved. Means kinetic energy isn't conserved, momentum remains conserved. Total energy remains conserved, here it is impacted. Am I clear till here? Yes, Tahura, Nabiha, Mariam. Okay, clear to Tahura. What about Nabiha and Mariam? You both are understanding? Are you?
Yes, ma'am.
Yes, yes.
Okay, please note it down then. The differences between elastic and inelastic also come in the exam. Definition of collision doesn't come, but write it. Okay, coming to the next topic, coefficient of restitution. Sanidhi, do you remember coefficient of restitution? Anything? Hmm? Yeah, Sanidhi,
Yeah, ma'am.
tell me something.
Ma'am, it is the ratio of
Ratio,
relative velocity
velocities. Yes.
separation to relative velocity of approach in case of collision between two objects.
Separation by approach. Okay. Okay, I'll discuss it. It will give you a revision. Okay, good. See, class coefficient of restitution, it's basically represented by this symbol E, and it's a very helpful constant that is useful to identify if their elastic collision is there, inelastic collision is there, or perfectly inelastic. You have one case that is perfectly inelastic. Perfectly inelastic means the body will stick to each other, means they won't be separated. That case is known as perfect, whenever the term perfect is given in collision. Okay, so E is equal to 1 for elastic collision, E is less than 1 for inelastic collision, and E is equal to 0 for perfectly inelastic collision. Now see, if you are given these values, you should be easily able to identify which kind of collision is present. And amongst inelastic also, you should be able to identify which kind of inelastic is given, perfectly inelastic or imperfectly inelastic. When the bodies stick to each other, that is perfectly elastic, and this E is equal to 0 in that case. Now, what is this coefficient of restitution? This is the case before the collision, this is the case during collision, and this is the case after collision. Relative velocity means the velocity with respect to each other. So here, the relative velocity means u1, u2 will be u1 minus u2. Now, usually we have the final minus initial whenever we calculate. Here it's u1 minus u2. Reason is that if u1 is not greater than u2, it will never overcome its speed and collide. It will always have this distance, and there won't be any collision occurring. Okay, so that's why u1 is greater, and we write the relative velocity of approach as u1 minus u2. Both of the bodies are moving and they are colliding among themselves. Now, this is the event where the actual collision amongst the bodies occur, and when they separate, they have their individual velocities present. So, the relative velocity of separation this time can be written as final minus initial, means greater minus lesser, that is v2 minus v1. And what is this coefficient of restitution case? Actually, it's the ratio of the relative velocity of separation and approach. Means E is equal to V2 minus V1 relative velocity of approach, separation, by U1 minus U2 relative velocity of approach. Using this, the formula, the value of E is calculated. Okay, is that now clear to all? What is this coefficient of restitution? Clear or not? Others, why don't you respond? Are you people listening? Mariam, Nabiha, Tahur, are you there in the class?
Yes, miss.
Then why isn't
Yeah,
any
ma'am.
response
I'm
from your
listening.
end? If you are understanding, you all keep your cameras shut, you all keep the mics shut, and when I'm asking you all, then you are not responding. See, this way, how would I know what you understood? Yes, Mariam, unmute yourself and tell me what have you understood. Explain it to me. What is coefficient of restitution? What have you understood? Yes, Mariam, let's start with you. Say something, I'll help you. It's not a test. Don't worry. This is not a test. I'll help you further. Whatever you can recall, things are there on the screen. I'll scroll it also for you. Tell me, what's coefficient of restitution? Try.
When it's to see how much energy is conserved.
No, it's a ratio. This is not related to energy. Okay, it's related to velocities. Fine. Tahura has left. She does this every time. That will not help. Just stay in the meeting even if you're not able to answer. Okay, see Mariam, it's not related to energy. Though the symbol E is written, it is related to velocities. Okay, and that to the relative velocity means velocity is with respect to each other. Okay, Mariam.
Yes, miss.
Nabia, you tell me whatever you could understand. Nabia. Yes, Nabiha, tell me something. Have you not understood anything?
Uh, Ma'am, it is velocity by collision.
It's velocity
The
by
symbol
velocity
is
only. See, it's
E. It is
velocity by velocity.
E, and the formula is V2 minus.
V2 minus V1 by
Yeah, ma'am.
U1 minus U2.
U1
See,
minus U.
I'm repeating, now pay attention. When two bodies are moving before collision, they have their initial speeds. Here, relative velocity is u1 minus u2. Relative velocity means separation velocities with respect to each other. u1 is greater in this case. Reason I told you was if u1 is not greater, the body which is lagging behind will not be able to overcome this and will not be able to collide. Okay, that's why this is u1 minus u2 because this velocity has to be greater. This is known as relative velocity of approach. When the bodies collide and they separate, their new velocities are their v1 and v2. So v2 minus v1 is known as relative velocity of separation, and coefficient of restitution is nothing but the ratio of these two, relative velocity of separation by relative velocity of approach. When you put it in for elastic collision, you will get it as 1. Inelastic, less than 1. Perfectly inelastic, 0. Perfectly inelastic means bodies will not get separated from each other. Now is this clear, Mariam and Nabila? Properly?
Yes, miss.
Anidhi?
Yeah, miss.
Okay. Please write it, then we'll derive it for elastic collision. Yes, Tahura, where did you go? Talking about the elastic collision in 1D, here we discussed the two factors, that momentum is conserved and kinetic energy is conserved. So initially, this momentum will be M1U1. See, what will we have? We will have the initial momentum equal to the final momentum. Initial means this, before part means M1U1. For this, it will be M2U2. Finally, it will be M1V1 plus M2V2. Now, let's bring the 1 terms together and U terms together. This will be M1U1 minus M1V1. This is equal to M2V2 minus M2U2. Okay. Now see, from here we'll take M1 common. This will be U1 minus V1 equal to, this is M2 V2 minus U2. This is the first point. Now what we'll do, we'll take kinetic energy conserved. So initial kinetic energy will be equal to final kinetic energy, means half mv1 square mu1 square plus half m2u2 square plus half is equal to half mv1 square plus half m2v2 square. See, from here half will be cancelled. What will be left? m1 u1 square plus m2 u2 square is equal to m1 v1 square plus m2 v2 square. Again, let's bring the one term together. m1 u1 square minus m1 v1 square. And this will be m2 v2 square minus m2 u2 square. Why are we doing this? So that we can have m1 taken common. So u1 square minus v1 square is left. And from here m2 is taken common. So v2 square minus u2 square is left. This is our second equation. Let's divide both of them. The first one from momentum and second one from here. This will be, see, if I have this as m1, u1 square minus v1 square is equal to, this is m2, v2 square minus u2 square is there. Divided by m1, u1 minus v1 divided by m2, v2 minus u2. What is this? These are the two equations that we are dividing. Okay. Now see, let's open up the brackets. Which identity is this? Can anyone tell me? Here, a square minus b square is equal to what? Yes, class, basic identity from mathematics of class 8th. A square minus b square. Answer.
A plus B into A minus B.
Very good, Mariam. A plus b into a minus b. So this identity will be used here, a plus b into a minus b. So here, when we put in the value, we'll get the m1 will be cancelled, m2 will be cancelled. So a plus b into a minus b divided by u1 minus v1. This is equal to v2 plus u2, v1 minus u2, v2 minus u2. So this will be cancelled here and this will be cancelled. Look, u1 plus v1 is equal to v2 plus u2. It means u1 minus u2 is equal to v2 minus v1. Take the ratios. Now let's put it here. What is E equal to? E is v2 minus v1 by u1 minus u2. In this case, both are same. Means they will be cancelled. It will give you 1. And that's what I told you, that E is equal to 1 in elastic collision. So this is the proof of it. Plus, the final velocities have these two formula. This is the first formula, u1 m1 minus m2 plus 2 m2 u2 by m1 plus m2. This is a final formula of the second. Means these are the final velocities, no, with which they move. M1 is there moving with velocity v1 and m2 is there moving with velocity v2. These are the formulas of V1 and V2. Okay, this is the first formula. This is the second formula. V2 is U2 M2 minus U M1 plus M2 M1 U1 by M1 plus M2. So these two formula you'll have to remember. But before that, write a derivation comes in the exam. Start writing from here. Okay, and if there's any doubt in between, please ask in between. Write it. Sanity, you can leave now. Time is up. You've already done this round. Okay.
Okay, ma'am.